Okay, this is section 2, which we get into the chemistry, atoms, molecules, and ions. This video, which it will be on the resource page, shows how sodium metal, which will burn skin, and chlorine gas, which is poisonous, react to form an edible compound. Dalton's atomic theory. Dalton was a British schoolteacher who basically recorded the weather conditions, whether it was rainy or sunny, snow, the temperature, and the atmospheric pressure every day. And by making these observations all his life, even though he was not a trained scientist, he was able to make some important contributions. We'll see him again in Chapter 5 with partial pressures. You also, in biology, a lot of times when you talk about the molar mass of a compound, they call it's in Daltons. He's also known for his important contribution towards color blindness. And that's an interesting story. So he and his brother were both school teachers, which in the 1800s was a very prestigious career to be in, well paid for career. And so in order to celebrate that, he and his brother decided to go to Harrods, which is basically like going to Macy's, a very expensive store in London, and buy their mother a Christmas gift of silk stockings. Now, again, 1800s, in order to get silk, it had to come by boat around South America, the Cape of Good Hope, from China in order to get to England. So we're talking a very luxurious item to have in the 1800s was silk stockings. So he and his brother bought their mother the silk stockings, and when she went to open it on Christmas Day, instead of being happy, she kind of cried out in horror, and neither brother could figure out why. I mean, this was a very, very nice gift, and they couldn't figure out why their mother was so horrified. Well, it turns out that the stockings were bright red. And if you study English Lit, you know that the scarlet letter, A, and it was scarlet to mean sin or prostitution. It turns out neither brother saw the fact that the stockings were red. They saw gray. And they kind of discovered from that it was color blindness. So Dalton's atomic theory says that all matter is composed of invisible atoms. In fact, to this day, with our most powerful microscopes, we still cannot see them with any device that uses our eye. Okay, an element has only one kind of atom. Okay, so all hydrogen, the element hydrogen, all the atoms are hydrogen. Compounds are composed of atoms of two or more elements, chemically combined in fixed proportion. And so, sorry, I'm not showing this over here. So this shows krypton, and they're all krypton atoms. This shows sodium chloride down here. So this is NaCl, and it's a crystal structure. Okay. And number 4 is that chemical reaction consists of the rearrangement of atoms reacting to give a new compound. So here I have methane, which is CH4, plus 2 oxygen atoms, goes to form carbon dioxide and 2 waters. What's important here is from the first chapter we learned the constant mass, okay? And that's because the number of atoms of each element stays constant. So I have one carbon, I have 4 hydrogens, and it's 2 times 2, so it's 4 hydrogens, and I have 2 times 2 is 4, so I have 4 oxygens. Here's 2, and here's 2. So the number of atoms stay constant, and it's just a rearrangement of those atoms that I'm looking at. This, I said that you cannot see atoms with the naked eye. This is true. This is called STM, or scanning tunneling microscope, and this is a method in which we can see the iodine atoms. So these are iodine atoms on the surface, on a platinum surface. Okay, and so only through these indirect methods, if you will, can we actually see individual atoms. All right, next is atomic symbols. It's the 1 or 2 letter notation used to represent. So this is helium. It's represented by He. Okay, very old elements have 1 letter, like carbon and hydrogen being H. Most letters, or most atomic symbols, are the first 2 letters if it uses 2, but sometimes you have more than 1, so you have to not necessarily use the first one. So zinc is Zn, and some are named after the Greek Greek element name, and things like silver is argium, and so it's actually Ag. So for each atomic symbol, give the name of the element. So Be is beryllium. Ag, I just said that one, is silver. Si is silicon. C is carbon. I gave that one away too. I expect you to know the first 88 of these. The periodic table that I give you only has the atomic symbols. They do not have the names of the elements underneath it. So you're expected to know the first 88. You'll kind of there will be some in that 88 that we don't use, but you'll kind of pick that up. But I could ask any of the first 88. All right, number 40 says give the atomic symbol for each of the following elements. Copper. Okay, copper is one of those that was named for the Greek name Cuprous, so it's Cu. Calcium. We already have carbon is C, so calcium can't be C, and so it goes with the first two, which is Ca. Mercury, again, is named after the Greek name, so it's Hg. And tin, also named after the Greek name. This one's Stannis. I happen to know that one, so it's Sn. So even though it's the first two, it's not the same there. Okay, so in chapter 1, we had the law of definite proportions. This is the law of multiple proportions, which I kind of talk about there also. The fact that if two elements form more than one compound, the masses are still in a fixed ratio. So basically, this is a continuation of constant proportions. Constant proportions says the fact that nitrogen monoxide, the ratio is always going to be 1 to 1.43. What this is slightly different, it's saying the fact that this ratio for nitrogen monoxide is different than the one for nitrogen dioxide. But I do it the same way. The atomic mass of nitrogen is 14. The atomic mass of oxygen is 16. So I divide both by the smallest number of 14. I get the 1. And then the 16 divided by 14 gives me 1.43. Nitrogen, I have one of them, so it's 14. But I have two oxygens, so it's 2 times the 16 to give me 32. Again, dividing by the smallest number, I get 1 to 14 divided by 32 is the 2.86. So this ratio will tell me whether the compound is nitrogen monoxide or nitrogen dioxide based on that ratio.